This video walks you through Lesson 24, where we talk about requirement derivation and analysis. So the first thing we're going to do is we're going to import a number of requirements into our magic draw model. You can see right here I have 5 operational requirements, which stem from your stakeholder and talk about how your system works in an operational setting. And then I have a number of system requirements that talk about the technical capabilities of the system that we then would hand off to our design team to actually build our system. So I'm going to close that Excel file. I'm going to import it directly into the model. So I'm going to go to Import from Excel CSV, Import using New Map. I'm going to select the file. For me, it's in my Download folder. And I'm going to select the import type to be an element, element type to be a requirement. I'm going to select the properties to map to include text and ID. Those were the header files, which are captured over here. I'm going to set the target scope to be in my requirement folder. So the next thing I have to do is do my mapping. Name goes to name, text goes to text, ID goes to ID. And again, these values on the right-hand side are the headers from my Excel file. And this is saying which property of my element maps to which of those columns. I'm now going to hit import. And we can see that all of those requirements are now imported into my file. Now that these are imported, the next thing I can do is I can show the mappings. So I'm going to show where my operational requirements come from, specifically what stakeholders they got generated from. So I'm going to create a diagram, requirement diagram. Nope, create a requirement table by accident. Let's say Control V to undo that, create diagram, requirement diagram, and I'm going to do operational requirement mapping. Next thing I'm going to do is I'm going to select the 5 operational requirements from my tree and drag them over here. There's one. Get them all online with each other. Next thing I'm going to do is I'm going to show where they trace from, which stakeholder has these concerns. So I'm going to go to my external stakeholder actors. Open all of these up. And let's see, so system shall be fully voice activated. That sounds like a soldier concern. So you can see all of the concerns are caught there. I'm going to go to those dots, tag value, do not display. Makes it a little bit easier to read. I'm also going to drag the unit commander over here. I'm similarly going to get rid of those concerns so they're not displayed. So this requirement traces from my soldier. This requirement traces from my unit commander. This one requires offline. That sounds like a G6 type thing. Let's get rid of their concern. Trace. Process data. That's definitely a soldier issue. I don't actually have to drag that. He's already on there. I can just trace it back to him. And shall be able to be used on long-term without resupply. That seems like it's both the soldier as well as, I think the unit commander cares about that too. So I can go to quick diagram layout, and you can see how my requirements map to my stakeholders. So I can create a requirement table pretty quickly from this, just because that might be a little bit easier to read for some stakeholders than this diagram. So requirement, create diagram, and create a requirement table. I'm going to call this my operational requirement. I'm going to go call it mapping again. I'm going to drag my 5 operational requirements and put it into the scope. You can see them appearing there. I'm going to collapse this column over here slightly just so that it makes it a little bit easier to read. I'm going to select columns from right up here. I'm going to go to traced 2. And you can see it's now populated out here where it's showing which, from whom each of these requirements is traced from. All right, that's great and everything. That shows my operational requirements. But the next thing I also have to do is show my functional requirements, or sorry, my system requirements, and how they trace back to my operational requirements. So I can create a new diagram, requirement diagram. I'm going to call it my system requirement mapping. I'm going to highlight all of my requirements, both operational and system, drag them onto the pane. And you can see that it's organized like that. I'm going to, let's see, what are my operational ones? So this one, this one, this one, this one, and this one. So I'm going to drag these off on their own. I'm just going to move these over slightly, just try to make it look a little easier to read. And now what I can do is I can show the mapping of each of my system requirements back to an operational requirement, where they're derived from. So for example, system requirement 1.1 shall process and analyze mission data. That's traced back to this operational requirement right here. So I'm going to zoom out slightly just so I can see more of these. Move these over so that they're all a little more visible. And I'm going to just show my mapping, or do my mapping. So 24 hours, that's going to be to OP5. Sorry, I clicked the wrong button. Now it's showing that the wrong derivation. So these are derived from that, data encryption, derived from that, data interface, going to go with that, durability, that, low battery warning, that, latency, go with that, memory storage, goes there, voice recognition, goes with that, offline battery life, goes with that, data processing accuracy, goes there, response time, goes there, temperature constraints, goes there, voice recognition accuracy, goes up there, voice recognition time, goes up there. All right, so we have a pretty nasty web right here. Make sure nothing's clicked. I'm just going to go to quick diagram layout, and it looks a lot better now. One other thing I'm going to do is I'm going to change this requirement right here. So it's 1.1. It says within 3 seconds, I'm going to change that to less than. You'll notice that it's now underlined. It means that system architect picked up that this is a Boolean, and this will be imported in a few minutes. We can also create a requirements table that shows this mapping. So if we go to create diagram, requirement table, and I'm just going to call this system requirement mapping as well. And I toss in all my system requirements. Shrink down this column. And now I can add in a column of derived from, and it shows me which of my operational requirements this is derived from. So now I have a pretty good mapping. I have a table that shows all of this. It makes life a little bit easier. The next thing that I'm going to do is I'm going to capture my technical performance measures and tie them to requirements, as well as tie them to elements of my model. So to do that, I have to actually start building my model out. So I'm going to go to structural model, create diagram, and I'm going to build a block definition diagram. And I'm going to just go ahead and call this logical architecture. This is more of a conceptual idea of what I imagine my system to be. Again, we're doing the running example of the Vista system. So on my top level block, I'm going to call it Vista. And I currently envision it as having 4 primary subsystems: my battery, my push to talk, basically a button that allows me to control the system and let know that I want to ask a question, a headset, which allows me to ask the question and hear the response, and my processor. Not all of my subsystems are created equally. We could imagine that most of the things that are happening are going on with my processor. So again, I'm in the conceptual phase right now. So if I look at what my processor has to be able to do, it has to do speech recognition. It has to do question processing, and it has to do response lookup. So let's go ahead and show the composition. All right. So I have this going right now. So the next thing I can do is I can start looking at, well, some of my requirements have some technical performance measures tied to it. Let's look at system requirement 5.1, battery life. So Vista shall operate for a minimum of 24 hours on a single battery charge. I'm also going to do system requirement 1.1, data processing time. So it says that I need to be able to have a response within 3 seconds. Just for ease, I'm just going to move these down for now. And I'm going to increase the size of my pane. So you can see right here that I have items in seconds and hours. So I want to go ahead and create my value types for those. So I'm going to do value type hour, value type second, and I'm going to generalize them to value type real. So they're real numbers. So the next thing I can do is I can start defining the characteristics of my system and those value properties. For my technical performance measures, if I'm saying battery life and response time are 2 of my technology performance measures, those would be at the system level. So let's go ahead and define those. So I'm going to hit on this black box right here, value property, let's call it battery life, one word. I'm going to give it hour as my units. I'm also going to add in another value property. I'm going to call it response time. I'm going to give it time of seconds. All right. So my battery life is going to actually be captured through my battery block. So I'm going to create a value property down here and call it battery life, hour. Even though they have the same name, same units and everything, Magic Draw won't necessarily automatically assume that they're related. So we have to create a quick parametric diagram to show that relationship. So I'm going to right click on my block, go to create diagram, and I'm going to create a parametric diagram. I'm going to include my value for battery life, and I'm going to create a block for the value for battery life in the battery block. So if I hit OK, we can see that we have these 2 values right here. One is that sub 1 under my battery, and one is at the top level system. I'm just going to create a binding connection between the 2, and we are good to go. So now if I hit this back button, I can go back, and they are properly connected. So let's just test this out. I'm going to right click on my block, go to simulation, and I'm going to hit run. So let's actually run it, press that green arrow. And if I go down to my battery, set it as having a battery life of 10, I forgot to do something important. Let's hit stop. I forgot to tie this value to the requirement. So I'm going to click on that value, specifically battery life, highlight the satisfy arrow, and drag it to that requirement. Now I'm going to run this simulation again, and I'm going to set my battery life at being, let's go with 10. You can see that it pops up red. This is red. Everything's looking bad right now because it's not meeting the minimum of 24. So suppose the value is 25 right here for battery life. Oh, turns green. Everything's good. If I do 24, okay, it still meets the minimum of 24. Go 23.99. Oh, now that's bad. So you can see that the software has a built-in ability to, once we set parameters and set it up so that the system level parameter is tied to the component level, we're able to compare it to the requirement and see if it satisfies it. So the next thing that we're going to do is we're going to look at the data processing time, which is going to be the sum of the speech recognition time, response lookup time, and question processing time. So I'm going to create a value property for each of those of time second. All right, so I have all those defined, but now I need to set so that response time is the sum of those three. So I can either do that in my existing parametric diagram or I can create a new one. Let's just create a new one. Diagram. And I'm going to look at response time, and I'm going to take those value parameters from down here, so QP time, RL time, and SR time. So all those pop up pretty automatically, and I'm just going to drag this one over here. So you can see that these three are the subsystem one. You can see the nesting with the periods there. This one is the system level one. What I have to do next is I have to sum them. So I'm going to create a constraint property. I'm just going to call it adding three values. So you can see that it's blank right now, so I need to add a constraint parameter. I'm going to go with I'm going to set it to be type second. I'm going to add in B of type second. I'm going to add in C of type second. And these are just variables that I'm defining in D of type second. So what I'm going to do for my equation now is say that D is equal to A plus B plus C. So if I set these three values over here to A, B, and C respectively, and this to D, the output from here will feed my response time. So let's go ahead and do that binding. And I'm just going to do quick diagram layout. And so right here, you can see that I'm just adding these three up to create this. So I'm going to go back now, and I'm going to say that my response time satisfies my data processing time. All right, let's go ahead and execute the simulation for this again. Hit run. So now we're going to look at the processor and look at the individual components there. If I set them all equal to 0.7, that would give that my total response time is going to be 2.1. So that's great. That's awesome. Now, if I set them all to be 1, my time is now 3. And you can see that my response time is not less than 3. It does not meet that requirement. So it does not, so it shows up red. Let's set this to 0.9 right here. So that's 2.9. So that's good. However, my battery life is still showing up red. So let's go ahead and set my battery as being at 25. That's green. Everything's happy. So while this is kind of a simplistic example, as you start building out models and they get more complicated and you have a lot of requirements, you can show these mappings and create these relationships. It is inherently a very useful tool in using model-based systems engineering.